In this lesson, we're going to learn about 1-degree motion, and we will learn our kinematic equations. So let's begin. When we want to indicate position, we will use a small case x. When we want to indicate a change in position, we will use delta x, which is our final position minus our initial position. This quantity is called displacement. And it bears noting that this is a different quantity from distance, which is the total distance traveled. Displacement is simply the difference between your final position and your initial position. For example, if I start at this box here, and I go all the way around here, and I finish at the same box, I have a displacement of 0. So my distance, of course, is this total, whatever the distance of this line is. But it bears taking note that displacement, which is a quantity that we will be using much more than distance, is what we are interested in here. Okay. If we want to know, study our velocity, we will indicate that with a small v. And this is delta x over delta t, which is x final minus x initial divided by t final minus t initial. And this is for your average or your or if it's constant. This is not for an instantaneous velocity when your velocity is changing. For that, we will have to take the derivative. So if we want the instantaneous velocity, we will use dx dt. Okay, so that's for v instantaneous. I'll put a subscript I. All right, finally, another quantity we will be interested in studying is acceleration. Once again, our average or our constant acceleration will be defined as delta v over delta t, and that will be v final minus v initial divided by t final minus t initial. Once again, if we want to know our instantaneous acceleration at any given point, we will have to take dv dt, the derivative, and plug in for our value of t that we're interested in knowing our instantaneous acceleration and solve that way. All right. So that is our definition. We will most likely not be doing too many problems with changing acceleration, but we will touch on a few. All right. Now let's learn our kinematic equations. The first one will be our displacement equation. And that is, these equations can only be used with a constant acceleration. These cannot be used with an acceleration that is changing with time. So displacement equation is x final equals x initial plus v at naught, which is v at t equals 0 times time, plus 1/2 acceleration times time squared. So now if we take the derivative of that, we get a dx dt. And the derivative with respect to t, if we're taking the derivative with respect to t, this will be a constant, so that's 0. So that's going to be equal to v naught plus a t. And this is our velocity equation. So dx dt equals v, and that's going to equal to v naught plus at. This is our velocity equation. All right. Next, we have an equation that we get from taking the average of our velocity. I call it the average equation. And that is x, our position, equals 1/2 v initial plus v final times time. So you see we're adding up our different velocities, dividing by 2. That takes the average and multiplying it by time. Finally, one that we get from energy considerations. Which we will learn about in subsequent chapters. And that will be v final squared equals v initial squared plus 2a delta x. And let's say we're solving for delta x. You should note that